I'll show you this little homebrew battery charger that I've made. It's for charging lipos, and you're probably thinking, well, single cell lipos as well. You're probably thinking, well, got chargers for that, but it's for these tiny little cells. This one is 30 milliampere hours, and it's for field charging them and actually measuring how much charge you put in them, and it can also discharge and do storage charges. So you can see it's running off a little 4.8 volt NiCad pack. If I zoom in a bit and maybe turn the backlight off, maybe we'll be able to see what's on the screen. So I'll connect the, you see at the moment it's saying we've got 4.97 volts available from the NiCad. The 0 milliampere hours have gone in. It's telling us to connect the battery. I'm going to connect that little 30 milliampere hour battery now. There we go. So it's saying it's currently got a charge of 3.75 volts in it, and the options are, I'm pressing the button under the where it says select now, and there's only three operations. We can charge, we can discharge, or we can do a storage charge. So if we go for charge to start with and press the start button, so now you can see it's saying, I wish this camera would focus better. It's saying charging. You can see at the moment there's 46.6, 46.5 milliamps going into the battery, gradually decreasing. The voltage underneath the word charging, that's the voltage of the cell. So we should see that rise a little bit. It's 3.85, there we are, it's just gone to 3.86. Underneath that you can see that we've put 0.6 milliampere hours into it so far, 0.7 now, and in the top right we can see elapsed time in minutes and seconds. And there's a stop button, and that's about it really. Now the way this works is it's very simple. It's charging just straight from the attached battery, which is this 4-cell NiCad at the moment. The idea is you connect nominally 5 volts up to this thing, so you could use a phone charger or a USB power bank, or a 4-cell nickel metal hydride or similar. And all this does is put the light back on. I'll zoom out a bit. You can see at the top on that sort of speaker connector part, we've got 4 sets of terminals. The leftmost one is the incoming power from the battery or phone charger or whatever you're using, and then there's 2 resistors, and then there's the battery that's on charge. So all this thing does is, inside there are some relays. If you ask it to charge, it connects the 5 volts incoming through the left hand resistor via a relay. So there's a relay that just closes when you ask it to charge, and it's basically connecting the 5 volt battery to the battery on charge through the resistor. And so you choose a resistor. At the moment we've got a 220 ohm in there, you choose a resistor suitable for the size of battery you're charging. With a 5 volt input and a discharge battery might be 3 volts or so. You've got 2 volts to start with. You just use Ohm's law and work out what current. And then obviously as the battery charges up towards 4.2 volts where it cuts off, you've got less and less head voltage between the supply and the battery you're charging, so the current will reduce. You can see at the moment we're down to 41.6 milliamps going in, and that's gradually reducing as the battery voltage comes up. Similarly, I meant to say, if you ask it to discharge, it just connects the battery through a different relay via the second resistor, which is 100 ohm in this case, straight to ground. And again, you just use Ohm's law to work out size of resistor you want to give roughly the discharge current. Of course, there you've got the full LiPo, lithium, ferrous, whatever battery you're charging. So it starts on 4.2 volts, and you work out what resistor you want to put in there to give the sort of discharge current you're looking for. Obviously you need to consider the power rating of the resistors. If you're using this to charge bigger cells, 18650s or something, then you're going to want to use 3 or 4 ohm resistors, but you're going to need them to be, 5 or 10 watt rated. For these tiny batteries, if you work out the dissipation in the resistor, which is I squared R or V squared over R, you find that for what I'm using here, quarter watt is plenty. So for these tiny batteries, we've got standard quarter watt resistors, and I've got a 22 ohm for charge and a 100 ohm for discharge. Now the inside there's a couple of relays, an Arduino to control it all. The display is driven via one of those I2C adapters to keep, so it doesn't need so many wires. And the heart of the thing that's measuring the current and the voltage so accurately is a little module called an INA 219 you can buy, and I think it's I don't know, how is it, 12, 14, 16 bit, I forget. Anyway, it's high resolution. You can see it's working down to tenths of milliamps and hundredths of volts. So it's a small module that the Arduino talks to via I2C, and it measures the voltage and the current of the battery on charge. The thing that's measuring the incoming supply, that's showing the 4.79 volts there, is just one of the Arduino's analog inputs, but that's just to give you an idea of whether the supply is healthy really. It's not critical to the battery being charged or the milliamps going in or anything like that. So you can see we're up to 3.94 volts now. I'll just disconnect the battery that's on charge, and you'll obviously that will cause the charge voltage to quickly go up above 4.2 because it'll be open circuit, and it'll cut off. So this is sort of simulating what would happen when it gets up to its full charge voltage. We'll just disconnect that, and you can see that the display starts to flash just to grab your attention if you're doing something else. You could put a buzzer on it, I suppose. You can see the clock stopped, and we've put 5.2 milliampere hours into that battery, and both the buttons at the bottom now are both reset. If I press one of them, it just goes back to the start. It doesn't erase that 5.2 how much has gone in, so you can still see that after it stopped flashing until you're ready to start the next charge or discharge operation. So if I connect the battery again, this time I'll go for let's go for storage. I've forgotten what the storage voltage is, but we'll see whether it charges or discharges when I start it. Oh, it's finished already, so the storage voltage must be 3.85 volts. So I'll stop that and we'll select discharge. So now you can see it's discharging. It shows the current flow as negative, minus 38.7 milliamps coming out of the battery at the moment, and it's taken 0.2 milliampere hours out of it so far. And you can alter the cut-off voltages for charge, discharge and storage in the sketch, but I think we're discharging down to 3.5 maybe at the moment, charging up to 4.2, and storage is about 3.85. So there we go. I'll put the I can show you the let's show you this Arduino sketch and the case while I've got the camera here. So probably can't see it anyway. There's the Arduino sketch. I'll upload it somewhere. Here's the case, designed in Fusion 360. And we can show the that's the connector block, that's the relay board, that's the Pro Mini, and that's the little INA module inside. If I hide the top, you can see. I will hide the connector block. That's how the electronic gubbins goes inside, and then above there the display module and the connector block are obviously mounted on the top. If I hide the bottom bits, what do we want to hide? The relay board, and I'll display the case top. So that's obviously, there's a couple of push buttons in there as well, and I'll stick the STL files as well, and the Fusion 360 if I can figure out how you share them, in case you want to use slightly different size components. Well, cheers, thanks for watching.